Okay, welcome to Polar Connect. We're really excited to be talking with teacher John Wood. And I think John's doing this solo today. All the researchers are out trying to get field equipment to the field site. But he's going to talk about the research project he's been working on for the past 3-4 weeks, maybe. Sometime since March. Time's been going away too fast, I think. It's already April 16th, 2012, and in a few moments we'll have an opportunity to learn more about what John's doing here. A few things about the Polar Connect platform we're using. It's called Board Collaborate, and you should be seeing a new slide, and that slide should be showing you some of the features of the platform we're using. I know a couple of classrooms have already tested it out, but you can chat through voice over IP, and to do so you need to click on the talk button, click it once to open the mic, and then you click it a second time to close it. We ask that you don't click on that when we're going through the presentation. We'll have time at the end for asking questions. There's also a chat room where you can post your questions as we go along and say hi, and also introduce yourself, where you're from, and how many students you got with you today. And if you have a question as we go along, or you want to say something, you can click on the little hand icon above the list of participants, and that lets us know that you want us to call on you. This event is being archived, and we'll send out the link as well as post it on the website. So before we turn it over to John, just a few things about why is John in Healy, Alaska, and what's he doing up there again with this researcher. He's part of the Polar Trek program, where we send teachers like John to the field with polar researchers both in the Arctic and the Antarctic. Nice shirt. He's showing off our logo. That's the Arctic Tern, and the Arctic Tern migrates from the Antarctic to the Arctic every year. So that's our logo for the Polar Trek program. Anyway, John's going to talk more about what he's doing here in just a second. So actually I think, participant introductions. We won't go around the room. We do have John's school on, as well as some family, and there's some other students as well that have joined today. Just type in where you're from again, and if you have any students or adults participating, an idea of what's going on. And then for video, one last thing, John is going to be the only person today that will have video, so we can see him when he's talking. And I think that's it. With that, I'm going to turn it over to your first slide, John, and I'll be quiet so you can tell us what's going on here.
Okay, well, thank you, Janet and Sarah, and everybody there at Polar Trek. I know there's a lot of folks working behind the scenes that have put in a lot of time for this, so thank you very much. And I want to welcome everybody today to the Polar Connect presentation. Today we're going to be going over, as Janet explained, my project, which is carbon balance in warming and drying tundra. And I'm going to be covering the winter only this time. So I've called it the winter edition, because for the last month we've been up here taking the winter measurements. And I want to remind everyone that I will be back up here in July for a couple of weeks, looking in on the summer operations and trying to get a better feel for what's going on the other half of the year. So I want to remind everybody of that. And I believe that's going to be somewhere between July 10th and about the 22nd or 23rd, somewhere around there. Okay? So thank you for that. And I'll go to the next slide. Now, who are we? Well, I have to apologize for Dr. Natali. She's not able to be here today. But Dr. Susan Natali works at the University of Florida. She is the chief scientist on this project up here and has been working up here for the last 3 years. Her experiments are on the warming and the drying of the tundra, although the drying experiments have just been recently started up at this point. And I will go ahead and explain now that these are real preliminary studies. And so don't have a lot of answers yet, but we do have a lot to look at and talk about. I'm John Wood from Talbert Middle School in the Fountain Valley School District, Huntington Beach, California, and I'm happy that everybody got in today to listen to what we have to say. So the next slide. Also absent, but wishes she could be here, is our one and only Elizabeth Webb, who is our field manager and soon to be a graduate student at the University of Florida. I have been up here working with Elizabeth now for the last month. And Elizabeth has been here pretty much all winter, taking measurements and collecting data for really the first time that this project has had the opportunity to collect a good series of winter data. So she's done a great job at keeping the equipment running in some pretty low temperatures. I think they reached -40 here at one point during the winter, and through some pretty extreme conditions. And as you can imagine, working in the field does offer its challenges from time to time. I also want to thank Dr. Ted Schuer, whose project started off this whole experiment here many years ago, 8 or 9 years ago, and who has given a lot of support to myself and to the project in general. Okay, so next slide. So I thought I would explain to everybody where we are first real quick and then move on from there. So we are in the state of Alaska, which is attached to Canada there, and we happen to be outside the town of Healy. So now Healy, Alaska, as you can see with the blue arrow, I hope, is about 100 miles south and a little west of Fairbanks, Alaska. So we fly into Fairbanks, and then we use a vehicle or whatever means to get out to Healy. The town of Healy is a pretty small town that sits just 10 miles or so away from Denali National Park. There's about 900 permanent residents that live in the town of Healy, and its main job site that goes around the town there is the coal mine that is just outside of town on the other side of Healy. Now Healy sits just outside of Denali National Park, and as it turns out, we're sort of in a cutout of the national park. So we're surrounded on 3 sides by Denali National Park, and then the highway runs through the east side. So that's where we're at. We're about 250 miles south of the Arctic Circle here. So we're not quite Arctic region, but we are subarctic. Okay, next slide. And specifically, where are we? Well, this is kind of a shot of the cabin that we are staying in. The cabin sits about 10 miles outside of the town of Healy, up what's called the Stampede Trail, which is mostly a road for a lot of it these days, but it's definitely a trail beyond that. And as you can see in the winter, there's a lot of snow that accumulates around the cabin, so we aren't able to get vehicles all the way up to the cabin. We can get them within about a quarter mile or so, and so we end up having to drag all of our equipment, all of our food, and all of our water, because as I have explained, it's a dry cabin, back and forth across the snow. So for the last month we've been hauling things pretty nicely, actually, because as long as the snow is hard and has a good surface on it, it's not really that large of a problem. It's turning into a problem now. Okay, next slide. Thank you. So let's get into the science a little bit. And I know the students have been reading the journals, and hopefully most people here today have been looking at the journals. So the first important question is, why did we choose this area for our experiment? Now I noted here that the experiment is referred to as CYPER, and that's pronounced CYPER as in viper. which is Carbon in Permafrost Experimental Heating Research. That's the official name of our experiment. Now, the reason that we're here in this area in general is the fact that over the last several decades, it is the polar regions that have shown the largest amount of change as far as temperature and ice cover and climate change goes. The polar areas have shown anywhere from 2 to 3 degrees centigrade temperature change since 1950. And it doesn't sound like a lot, but it has wide effects on the ecosystems, and eventually those effects will ripple down to all of the areas of the planet because all of the ecosystems are related to each other. And we're feeling the effects just further and further away from the poles as this intensifies. Now, we're also in a area where there's a lot of potential for positive feedback. And I've talked with the kids about positive feedback before, but you know, basically what we're looking at here is the aspects of the polar regions changing. And in terms of, say, like albedo, which is the amount of reflection that the surface of the planet gives and bounces light back off. The albedo itself is changing in the polar regions as the ice caps decrease in size. That nice white snow and ice doesn't cover as much land and area, and then what happens is the darker land and the oceans that are very dark go ahead and absorb more of the sun's energy, which causes the temperature of the atmosphere to increase even more. And so the more feedback, the more ice that is disappearing, the more you get sunlight being absorbed into the planet. So it sort of starts feeding on itself. And the more sunlight then is going to increase the temperature. So that's kind of what we mean by positive feedback. In the same way, we're looking at the carbon balance. So the carbon that is being held in the tundra really represents a huge amount of the carbon that is going to be or could be available to the atmosphere. As it turns out, the carbon that's in the soils is approximately twice as much as what we have in our atmosphere today. So if you can imagine, if all of that carbon was released from the tundra areas around the world, around the Arctic, it would more than double the amount of carbon that's in our atmosphere today, in the form of carbon dioxide and methane and several other gases that are considered to be greenhouse gases, which would cause the temperature of the planet to increase. Now, we're in the Healy region specifically because the Healy region represents an area of what's called discontinuous permafrost. And what that basically means is that I can travel north of here and I can travel south of here, really short distances, and I can find areas where the permafrost really does not exist. The temperatures are high enough most of the year that we don't get a lot of permafrost in some of these areas. And some of the areas are easily spotted because you can see the spruce trees growing in those. They turn into quite nice taiga and forest areas. Okay. So that means it's discontinuous. You're getting spots. Now, and that represents the fact that we are really on the edge of the change here as far as the northern polar region is concerned. It's only going to take another degree or so of temperature change in this area to really affect the soils and to really get a large amount of melting and thawing that's going on in the tundra, which predictions are that will release more of the carbon into the atmosphere, and then that positive feedback begins to happen because as the temperature increases, then more carbon will be released. Okay? Okay, next slide, thank you. So specifically, what have we been doing here for the last month? And what has Elizabeth been doing for the winter? Well, our daily routine does consist of what we refer to as our smiley plots. And you can see Smiley there in the center. Smiley is just a cute name that we've given to the sensor that we put into the ground covering our study areas, and it helps us collect the carbon dioxide that is coming up out of the tundra. Now the smiley plots themselves are really what I'm going to refer to as natural control sites. They are really not part of the experiment at all. They are put off to the side in an area that we don't disturb and we try to be in as little as possible. Now the smiley plots are there to really give us a background as to what the natural tundra is doing now. So we haven't treated it with any of the experimental treatments. We haven't done anything to it. We're just putting our sensors there over random sites of tundra, trying to get an idea of what the tundra would be doing anywhere in the area around us. And in the long term, that's going to give us a good baseline and a better understanding of what naturally occurs in this area. Okay, next slide. Now this is a graph from the smiley plots, and very simply put, it's indicating that the tundra has a natural tendency to give off carbon dioxide during the winter, which is extremely understandable. So if we're looking only at the winter operations, the tundra turns into a carbon source to the atmosphere because it is contributing carbon to the atmosphere. So we refer to that as a source. You can see the red line along the bottom are the smiley plots that are under shallow snow cover. So there's not a lot of snow on the top of them. And the carbon dioxide flux or change that is coming out of that tundra is increasing just a little bit. Just a little bit. However, if you look at the blue line, that data was taken from the smiley plots that are under a deeper snow cover, meaning more insulation from the atmosphere. And in general, those plots are giving out a considerably more or higher amount of carbon dioxide than their neighbors. So again, these are just the natural readings that are going on in the area. This is really not part of the experiment. This is what we would expect to be going on anywhere out in the tundra during the winter. Okay, next slide. The other part of our routine for the last month has been the winter warming experiment itself, which I've been referring to in the journals as the snow fence. And I'm going to go through that very quickly and recover some of the information that I've covered in some of the journals. The snow fence areas are the main experiment. And this is really the first year that we've been able to collect, with Elizabeth's help, a large set of data during the winter. As you can imagine, winter data up in the Arctic is really, it's not rare, but it's really not abundant because of the weather conditions, because of the remoteness of a lot of the work sites. It is very difficult to retrieve data in the winter, and it has been historically. So as the technology gets better, we will hopefully make some inroads into that. Next slide. And I'm sorry, I'm moving the camera around a little because I guess I'm getting some bad sunlight. Okay, so here is a picture that shows the contrast. Now, not only are we dealing with different situations of snow just each year, but we're also dealing with variations in the experiment. So if you look towards the top of this slide, this is what the winter snow cover looked like in 2011, almost exactly a year ago. And you can see that the fence sitting there in the center has done its job. The wind is coming from the right of that slide across to the left, and so as it reaches the snow fence, the wind and the snow that it's carrying will be disrupted, and then the snow is dropped on the leeward side of the fence, causing the snow to accumulate and leave a thicker blanket there. The bottom picture shows the same phenomena, shows the same experiment a year later. This is the winter snow cover this year, and I just took that picture a week ago. So not only are we looking at variations in snow cover experimentally, you can see how just naturally the variations occur from year to year. There's a lot more snow this year that has accumulated than there was last year. And from what I understand, the year before, 2010, the snow was even less than 2011, and it has fluctuated quite a lot over the years. So it's not just a matter of getting one set of data to represent everything that's going on out here. As the natural conditions change, we need to collect many sets of data, get a larger sample size, to really get a more clear picture of what's going to be going on in the long term and what possible cycles there are out here. Okay. Now, remember that top photograph there from 2011, because I'm going to show you the data that's directly from that fence area. And next slide, please. So here, what we've done is we've measured from the snow fence, along the snow fence we've measured every 2 meters, and out from the snow fence we've measured 10 meters. So we've sort of made a grid out from the snow fence, and we measured the snow depth. And from those measurements we create a profile of what the snow depth is going to look like over the study site. So as we look at this graph, and go ahead and, yes, thank you. As we look at this graph, you can see that the wind is coming from the right to the left. The snow fence itself on the x-axis is right at 0, where it goes down there. And then you can see that the natural snow cover is on the right side in the blue, and the experimental or induced snow cover is going to be on the left side, and you can see how dramatic that cover is. So that's giving us our snow blanket, our insulation there, which is eventually going to warm the soil. And that's why we refer to this as a warming experiment, because the snow is acting as an insulator between the atmosphere and the soil itself, which allows the soil to not cool down or stay a little warmer than what would naturally occur out on the tundra. Okay, next slide. And here is the soil data. This graph shows the data collected from the soil sensors underneath the fence that we've been looking at from 2011. The warming side of the fence, which is the side on the left that had the more snow, is going to be the darker line in this graph. And that darker line is generally on top there. And then the control side of the fence, yes, the control side of the fence is going to be the lighter lines, and that was going to be on the right side of the fence with the natural snow cover, the less snow cover. So you can see here, just glancing at it, we've put sensors in at 5 centimeter depth, 10 centimeters, 20 centimeters, and then 40 centimeters into the soil, and we've been recording the temperatures all winter. Now these are basically the maximums or minimums, depending on what you're looking at. And you can see in all depths, the darker line has been the warmer situation. and that is the temperatures that were taken from the warming side of the experiment, the left side, with the higher snow cover. So indeed, the snow cover is insulating the ground and causing the ground to be warmer on the experimental side, considerably warmer, when you can see at times the control side is getting down to -10, and the experimental side is still up above -4 in most situations. So that's quite the change. Okay, next slide. Now, I'll try to complete the picture here. Once we've looked at the snow fence, the experimental warming side, and the control side, once we understand that the ground temperatures are different on both sides, now we're going to relate that to the carbon dioxide that is being released from both sides by the decomposers and by the process of respiration that's going on with those decomposers. However, again, now look at the graphs. And I apologize, the graphs are not equalized as far as their scale and everything. But this is what I could put together at this point. So we'll look at the top graph first. It's the control graph. And basically what I want the students to notice is the slope of the line. We're looking at that red line, and you can see that the slope of it, it's going up at a certain angle. And now that sample was taken over 2 minutes, and if you look at the scale, it's really only going up a few ppms, a few parts per million over those 2 minutes. It's only going up 5 or 6 parts per million. So on the control side, the carbon dioxide levels are increasing. The tundra is that source, giving carbon dioxide to the atmosphere. Now let's look at the bottom graph, and this is taken from the warming side of the same fence. Now, this is over a shorter amount of time, and it starts at a higher level, but you can see the slope of that line is now much more pronounced. It is going up much faster. So even if we look at it from a 40-second rate, that line has climbed 70 parts per million, which is many, many more times higher than what the control side is doing. So the warming of that left side of the fence, the leeward side of the fence, is having the effect that we expect. It is causing that tundra to release carbon dioxide into the atmosphere at a higher rate. Okay. Now, this all relates back to the positive feedback that I mentioned before, because as that carbon dioxide comes out at a higher rate, it's going to affect the atmosphere. That greenhouse gas, carbon dioxide, is going to affect the atmosphere more, which is only going to cause things to get warmer, which is only going to cause more carbon dioxide to come out. So we're back into that positive feedback again. Okay? Next slide, please.
Hey, John, we have a question.
Okay, yes, please go ahead.
Okay, so one of your students, Samantha Haynes, wants to know, are you testing soil to see what type of plants grow there and how they can survive?
Okay, very, very good question. I'm glad you asked that. And yes, and you know what, if I had more summer data right now, I would be talking to you about all of those plants. I would be showing you all of those plants, and I've got a little slide here for you specifically that you're going to see here in a few minutes. But yes, the plants are going to play a major role. But of course right now, in the winter, you're not seeing most of the plants. The plants are under the snow. And photosynthesis, what is it doing right now, class? It's not doing much of anything. In fact, photosynthesis really can be measured at 0 right now. So those plants are sitting under there asleep, or just waiting for their chance, because even the ones that are poking through really aren't very active right now. And certainly the ones under the snow are getting no sunlight whatsoever. Okay? So, and we'll talk about that a little bit more in just a second. Does that answer the question?
We'll let them type that in, and we have a few more.
Okay, so another question from your students, Renee Garcia, is what's your favorite scientific tool to use? And you can address this now or you can wait at the end, but either way.
Okay, well, Renee, good question. And my favorite scientific instrument that we've been using out here right now is really the instrument that you guys used back in the bowl area with Dr. Natali, and that is the infrared LICOR system, the gas analyzer that is measuring the amount of carbon dioxide that's coming out of the tundra. It still amazes me, and we've gone over it, that you can take an instrument like that and you can measure parts per million of these substances coming out of the tundra and moving into the atmosphere. It's pretty amazing.
Okay, and one more question before you continue. So Tristan wants to know how much carbon is contained in a cubic yard of permafrost?
That's a great question. And if I had Dr. Natali sitting here, I could probably recall, or I could have her tell you. And I'm sorry, I'll have to check on that to really be sure.
All right, and another one that's coming up, and then we'll let you go. It says, Ashley Campbell wants to know, why are the depths of the test of the snow 5 centimeters, 10 centimeters, 20 centimeters, 40 centimeters? Why does it skip 30 centimeters?
Okay, Ashley, good question. And you know what? It's sort of like any experiment. You know, we could put a sensor at 1, 2, 3, 4, 5, 6, all the way down to 40. That's going to be a lot of sensors, and it's going to be a lot of things that can just go wrong and everything else. So what we'll do is we'll try to get as many good samples as we can, and then we'll kind of estimate or extrapolate the data. And so if we put a sensor in at 5, and then we put a sensor in at 10, we can see the changes between those two areas, and you can get a real good idea as to what that temperature had to do or is going to do to get from one point to the other. And then continue that down to 20 and then 40 centimeters. Hopefully in the future we can get those sensors down even a little deeper just to see what's going on, because the permafrost does extend down more than that. But I'll tell you, it's really hard going getting those sensors down into that solid ice.
Okay, great. So let's go to this slide.
Okay, thank you very much. So now let's try to bring this a little bit together right now. And as far as the winter is concerned, the question we're looking at is how much carbon dioxide is lost during the winter. What does that side of the equation really come out to be? And I have to say, at this point, our preliminary research, we haven't really got a good quantitative estimation as to what that is right now. We do know, however, that during the winter, the tundra is a huge source to the atmosphere. And as you can see on the slide here, the soil microbes, the respiration that's going on, the decomposition that is going on under the snow, even at those low temperatures, is enough to release that carbon dioxide all winter. And photosynthesis is at 0 right now because the plants just really aren't doing anything. And that's the way they planned it. They're all getting ready for the spring. They're all getting ready for the growing season. Now, I am going to talk for just a second about the summer, and I'm going to show you this next slide. And the next slide is virtually the same photograph that you're looking at right now. And this is what the students haven't seen, and this is what you'll get to see more of in July. But go ahead and change the slide. Okay. This is the tundra in the summer. And this is the same picture as that one we just got through looking at in the winter. So look at the dramatic change here. And I know I've had a lot of questions from the students about plants and, you know, what's going on with them. And if you're anything like me, unless you've really seen the tundra, unless you've really been out here, your idea of tundra is sort of scraggly little brown sort of, you know, plants trying to eke out a living. But look at this picture. That is nice and lush and green, and there are dozens of varieties of plants that are growing there and doing their thing during the summer. So let's look at the equation again, because that's the other half of the equation. We still have the carbon dioxide being released from the tundra through respiration and decomposition and all of the soil microbes and everything down in there, and as the plants decompose. Okay, only more so because in the summer now the temperatures are up. The active area of the tundra has gotten wider, meaning that the tundra is thawing out. And so now instead of just ice in the soil, we've got water in the soil. Water that's going to be available to the plants, water that's going to be available to everybody so that they can get active again and start doing their thing. So photosynthesis now in the summer really begins to take off also. So now the system is in full bore. The respiration is really cranking out the decomposition, CO2. But on the other side of that, the carbon dioxide is being pulled in by those plants in the process of photosynthesis. So, what our job is going to be, and has been over the last couple of years, is we need to take that equation, we need to look at both sides of that, and we need to get a good solid number that's going to represent that carbon dioxide in through photosynthesis as a sink, and that carbon dioxide out as decomposition and respiration as a source. And we're really going to have to look at sort of who wins. It's kind of like a bank account. You put money in and you take money out. And at the end of the year, if you put more money in than you took out, then you've got a sink. You're going to have money in savings. But if you took more money out than you put in, which is hard to do, you're going to have a source. And then you're going to be short. And that sort of represents that carbon dioxide coming out into the atmosphere. So that's really the job that we've got ahead of us, to find out what that balance is. Okay? Next slide, please. So, enough about the science. What else have we been doing since we've been here? Now, I've been helping Elizabeth quite a lot because she really knows what she's doing, and we've been taking measurements every day and going out to the field site. But we also did some student manufactured experiments, and we also had a little bit of fun. So next slide, please. I hope most of you will remember that we did our boiling water experiment, turning boiling water into snow. We really, by the time we got it together, the lowest temperature we could come up with was -18 Fahrenheit. And so we tested that out. And sure enough, the hot water getting ready to vaporize, you throw that up in the air, the surface area really decreases, that temperature shoots in there and it sort of flash freezes it. And it's pretty neat to see that water turn to sort of a powder and just kind of drop to the ground. So that experiment worked out very nicely, and that was some great suggestions from the kids. So I hope you guys all got to see that and read about that. Okay? And then the next slide. We also took another student experiment and asked, okay, do bubbles freeze? And at what temperatures do bubbles freeze? Well, we did a couple of experiments at -18. We also did a few extra ones at all the way up to -8. And we found that at varying amount of times, the bubbles would freeze. And the cool thing about that was that the bubbles themselves would kind of hang in the air, and under the lower temperatures, they would really drop down a lot faster as they went ahead and froze. And then they'd sit on the snow, and it was really cool to go ahead and poke at them and see that they've turned into sort of a very thin cellophane sort of feeling material. It was really much more solid than I would have expected it to be. And I have to give another shout out to Megan Shute for supplying the bubbles. Thank you, Megan. And yeah, they worked out really, really well, and we had fun with that. Okay, and I hope you guys saw that journal. Okay, next slide. And of course, there's always the dogs. And that is Tamale there in the center. And the bottom left is our winter shrimp. So he got in there. And then we've got Sky and Taxi and Biscuit and a whole bunch of other dogs. And every Sunday I've been doing that. So, and the dogs really are fantastic animals. It's great to have them around. Since I put the slideshow together, we did have a chance to see the aurora, which were spectacular. And we have had a chance to get out with the dog sleds now a couple of times, although that's gone now because of the snow conditions. But it's just fun to see dogs that are really well adapted to their environment and out there enjoying themselves because they really love to pull that sled. Okay, and next slide. And then we were fortunate enough to get into Denali National Park one time during the winter, and almost every time we've had some really clear shots of Mount McKinley there in the background. And we were able to do a couple of hikes and saw some pretty interesting things. And most of you are familiar with the tree branch that was stripped, and we're trying to figure out who and what could have possibly done that at that sort of height. So I think we're still getting suggestions on that and working on that. I can tell you that there was, and a couple of students did pick up on that, there's a fair amount of moose duds right underneath those branches there. So yeah, that may or may not be the actual clue. Okay, and next slide. And I would like to cap it off by letting Tommy say thank you to everyone for supporting this expedition. Talbert and Fountain Valley, Polar Trek, University of Florida, Mike and Crean here, and everybody that's had a hand in making this all possible. And I really would like to thank all of the other schools that have plugged in today. I hope that this is shedding some light on some science for you folks, and I really sincerely hope that you continue to contact my expedition, because it will be active for months and months, as well as the other expeditions that are on the Polar Trek sites, because there is a huge variety of science going on, and there's a lot of things to discover. And I think this is a fantastic tool for the kids. Okay, so thank you all very, very much.
Great job, very nice. All right, we had a question that came up while you were presenting, which I'll ask in a moment. I just want to remind people that if you want to ask your questions, Sarah just pushed out the slide about how to ask questions, but this is a great time if you want to ask them live to John and have him respond to them. But Joshua had a question that came up earlier. Is the unusually warm temperatures related to the increase in CO2 in the atmosphere?
Okay, Josh, that's a very good question, and I'm sure a lot of people have that. And you know what? That's the difference, and we've talked about this, and for everybody else, that is sort of the difference between weather and climate. So we're looking at the weather right now, and the weather is heating up what seems to be an extraordinary amount. Okay, certainly much more than last year and certainly earlier than last year. But on a short-term glance, we can only really look at the weather because the weather is going to change, and you guys know that, and the folks back in Mattapoisett and back in Massachusetts and New York and New Mexico that are here today, you all know how much the weather changes. But the climate, we're really not going to be sure what effect the CO2 is having as far as climate goes in our area for another few years. We need to put a string together and then look at the weather patterns over a longer period of time. So it's really hard to make a conclusion on that right now. But it's a great question, and we're definitely watching for that.
Okay. We're waiting to see if Jennifer and your students at Talbot want to ask their question live. In the meantime, you can address this one. Griffin and Samantha want to know about the weather, or the highs and lows that it has been while you've been there.
Okay, well, good. Well, I'll tell you, it actually got down by our thermometer soon after I got here. It was, in the evenings, it was down to about -25, -26 Fahrenheit. And so it was pretty chilly when I got here. During the days, it was just not getting above 0 back in those weeks. But our maximum temperature now, it got up to, I think they recorded, 54 yesterday is what I saw, 54 degrees Fahrenheit. So, I mean, that is very, very balmy. And I've mentioned this to some of the students, and I'll go ahead and mention it to everyone. In the summer, the Healy area, it's not uncommon for it to get up into the 80s here. So, and again, I know I've talked to my students about being away from large water sources. Well, this is central Alaska, and the temperature swings here quite a lot. We're not near the ocean at all, and we're not near any large bodies of water. So we're in the interior, and these temperatures are not out of the ordinary.
Okay, so let's see if your school is ready to ask their questions live. So Jennifer, remember to click on the mic, the talk button once to open the mic, and then as soon as the student asks their question, click the mic again to close it, and then John can respond.
Okay, hello. Thank you so much, Mr. Wood, for sharing everything. The kids are excited. So go ahead, give your clap now. Okay.
Okay. We only have them for a few minutes, so let's take good advantage of that.
All right, Mr. Wood. So here's Rene Garcia and his question.
Mr. Wood, what is your personally favorite dog?
Well, Renee, I knew somebody was going to ask me that, and you know I don't have favorites, okay? I'll tell you, the dogs are great. I love them all, and they're just neat. And, you know, once you get to know them, you know, they each have their own special little personality, their own little quirks, and I don't think I could name one that I would like to bring home over several of the others.
Okay, another question.
Okay, here's Isabella Gonzalez with her question.
Do you work in different places, or do you just stay in one place to work?
Okay, good question, Isabella. You know what, the study site, we go out to the study site every day, and that's pretty much in one place. So we've set up the experiments in one part of the tundra that we hope represents, you know, the greater area of the tundra, and we look at that. There are times when we will go out into other areas and do some sampling just to check to see if things are in line or if things look like they're happening a little different somewhere else. But in general, we're pretty much in the same place every day.
Okay, thank you, Mr. Wood. Here is Samantha Haynes. She's been busily writing a ton of questions up here, but I told her to narrow it down to one, so here it goes.
How long do you spend outside doing your tests?
Okay, Samantha, good question. Well, as you can see there, no. You know what? We will spend anywhere from 6 to 8 hours and more if we need to, depending on how the tests are sort of running that day. There are days when it's windy and you know, you kind of have to stay out there a little longer to make sure that the instruments are collecting the data properly. And there's other days where things are going fine. Some days the equipment just kind of messes up a little and you have to start all over again. So, you know, we go out to the field in the morning, we take some food with us and a lot of water and everything. You kind of plan to stay out there all day, and when it's over, it's over. And then you come back and get ready for the next day.
All right, thank you. Here is Maxwell Harrigan with his question.
What is your favorite thing you've done so far in Alaska?
Well, hey, Max, good question. You know, my favorite thing, I don't know, the dog sledding is pretty tough to beat. I personally love just getting out and hiking, and the area here is spectacular. It's really easy to just get off and be by yourself and see some really cool things going on. I kind of apologize for there hasn't been any, you know, large critters running around the study site yet, but in July we will get some of that, and you guys will see some more. It's all pretty cool, just being out here.
I'm sure you are definitely very, very busy. Okay, we have two more. Ashley Campbell is here.
When I saw the video of the bubbles, they didn't freeze right when they hit the, they didn't like pop when they hit the ground. Why is that?
Okay, good observation, Ashley. Well, mostly because they were freezing before they hit the ground, especially at that -18, which I took the video of. So they would actually, and if I could have shown it to you a little better, you would have seen that when the bubble hit the ground, it sort of crushed a little at the bottom, like it landed there, instead of just being the bubble that you think of as just going to, you know, touch a piece of grass and pop or something. They were quite solid as they were getting close to the ground there.
Okay, one more. Mr. Jonathan Palafudes has a question for you.
Is there any life under the permafrost layer?
Good question, Jonathan. Okay, life under the permafrost. There's really not. You do have some decomposition going on, probably down there, but not under the permafrost, because the permafrost, depending on what area you're in, the permafrost can extend a long ways down. Okay, so, and we're talking, tens and tens of feet way down into the ground as you move further north. So it really depends on where you're talking about. But the decomposition and the bacteria and everything in the soil do work their way down there further than you would expect.
Okay, great questions from your students there. So we have a question from Jade. So Jade, go ahead.
Hi there, John. So I am from New Mexico, and we have definitely been experiencing weather changes over the last few years. You know, crazy temperatures of 113 degrees in the summer, more rain than usual, less rain than usual, all kinds of stuff. And I've also been studying in my various science courses the effect that this kind of heating process is having all over the world. And to me, it's kind of clear that the world as a whole needs to address these problems, because we all seem to be caught in this giant positive feedback loop of these trapped greenhouse gases. And yet there are so many skeptics, especially in governmental organizations, who are claiming to not really believe in global warming and are not really addressing these problems. So is this research that you are doing able to be used or going to be used to sort of illustrate to people what exactly is happening?
Okay, Jade, thank you very much for that question. That's very well put, and I couldn't agree with you more. We need to adopt an attitude that we are all in this together. And I think a lot of people have misconceptions in that, we get some heavy snowstorms and things in areas, and they talk about, well, global warming or whatever, what's that all about? But the fact of the matter is, I think they're finding that the changes in the climate is affecting, both ends of it, the severity of storms and the frequency of storms, and also the extremes in the temperatures that we're seeing in some other areas. So it's happening cold and warm. It's changing the patterns all the way around. To answer your question, our research is, and you can imagine, it's such a small part of the global effort that's going on right now. But it is adding to the baseline data, and it will be used down the line to, give some credence and give some stature to the observations and to the conclusions that I'm sure, I feel positive, the more and more of the world will come to over the next few years. I think we're a little late on jumping on the wagon, but if you look around, things are changing in the politics. Conversations are going on that weren't going on, and the dialogue itself has changed. We're no longer arguing about whether or not something is going on. We're now arguing about, what the severity of it all and what it all means to us. And to close that idea off, I'll tell you, it's going to come down to money. It's going to come down to economics. It's going to come down to having to deal with these things for generations to follow. And I do hope that our research does contribute to that in a meaningful way.
Great question. Okay, Jade, let's see. I think we should wrap up. Your students are getting ready to head out the door there as it is. So we want to say thank you and let people know that we have other live events coming up and that you can join us for any of those. Also, we have more teachers heading to the Arctic over the summer, as well as some people heading into the Antarctic when school starts up again in the fall. So stay with Polar Trek. Lots happening in the next 6 months or so. So let's see. If you guys want to, John, if you want to say something, we will stop the recording in the meantime and let people say goodbye to you, and thanks.